Okay, hello everybody. Hello everybody and welcome back. Thank you for tuning in again. So now, in the previous lesson, I gave you a list of formula and I gave you some definitions, okay? So welcome to lesson 2. Yeah? So now for lesson 2, we're going to do question 6 here. So we're going to use those formula from lesson 1, the introduction. And we're going to see how they work here, okay? So I have a question here. No? This is question 6. It's from, I think from KZN. Yeah, I think from KZN. I guess it's not written here. Okay. So we're going to do it together. So such that we see how the formula, how it works based on the information. So now, let's get into the question. They say what? A solution of potassium hydroxide. Yeah? A solution of potassium hydroxide, KOH, is prepared by dissolving 3.36 grams crystals of potassium hydroxide. So KOH, potassium hydroxide. So 3.36 grams of potassium hydroxide in 250 cubic centimeter of solution. So again, our volume is given in cubic centimeters. You see? So our volume should be in cubic decimeters. So what do? We should change the cubic centimeters here. So 250, we start by conversion. Okay. 250 cubic centimeters will be equal to 250 and then over what? Over 1000. And then when we divide by 1000, it changes to cubic decimeters. Okay, so this is how you change from cubic centimeter to decimeter. If we divide by 1000, it changes from centimeter to cubic decimeter here. So you use your calculator here, it gives you 0.25 cubic decimeters. So, okay. So 6.1, they say define the term concentration. Okay. So we start with the definition here, 6.1. Okay. We start with the definition. So concentration is the number the number of moles of a substance per cubic decimeter. Per cubic decimeter. That is the definition. Right? Say define concentration. 6.2. What are they saying? Calculate the concentration of potassium hydroxide solution. So they gave us the what? The mass. They said grams, okay? grams means this is a unit for mass. And then we must find the concentration. Okay, because what do we know here? We know that the formula for concentration is what? C equals to N over V, isn't it? But then we don't have the N, isn't it? So we have to find the N first before we can use this formula, you see? So we're given the mass for 3.36. So the first thing we must do is to find the N in order for us to calculate the concentration. So use the formula for N. N equals to mass divided by molar mass. I said what about the capital letter? I said that the capital letter is obtained from the periodic table, the capital letter here, the bottom, the denominator. Okay, so they're talking about KOH. Potassium hydroxide is KOH. So we must look at the K, the O, and the H. Okay, from the periodic table. So the periodic table is over here. Okay? The K is how much? The O is 16, H is 1, and then the K is what? 39. Okay, it's going to be 39 plus 1 plus 16. 16 over here, so the number at the bottom. So here we have 39, here we have 1, and there we have 16. So we go back. So on the formula here, because that is KOH, okay? So maybe we should write here that what? Should indicate here. This is the number of moles for KOH. Okay, let me do it this way. So its number of moles is M over M. And then for what? For KOH. So this is going to be equal to, so at the bottom we have 39 plus 1 plus 16, the one that we got from the periodic table. And then the mass is 3.36. So the 3.36, where did we get it? From the question, isn't it? They said dissolving 3.36 grams crystals of potassium hydroxide. So this gives us, you use your calculator, here you have 3.36 over 56. More. So now when we have the number of moles, so it gives me 0.06. So you're rounding off to 2 decimal places. Okay. So now then that we're here, then we can then use the formula for the concentration, I mean to say. So we can say C equals to N over V, because we did find the N now. So now we can then use the N that we found here, 0.06 divided by the volume, which is 0.25. The 0.25 comes from where? It comes from here, isn't it? The volume that we converted. So we don't use cubic centimeters, we use cubic decimeters. And then, so again, you use your calculator here. And how much do we have? So it's 3 point. It gives me 0.24 mole per cubic decimeter. Okay, so what we had to see here is that we don't have the N. So the question is not asking us to find N, it's asking us to find C, isn't it? But then you can't have C without what? Without having N here. So that's why we had to find the N first. Okay, that's why we had to find the N before we could come here, before we can come here to find it. Or you can do it the other way, isn't it? Which the question is asking us to find the concentration. 6.2, calculate the concentration of potassium hydroxide, which is KOH, potassium hydroxide, KOH. So, or you can do it this way, okay? Or we can use the other formula, isn't it? Or we can use the other formula for concentration, the one that doesn't have N. So we can just say C equals to M divided by MV, isn't it? So again, the capital letter here, we have to add 39 plus 1 plus 16. And then the volume here, the volume is 0.25. So it's 0.25. And then the mass is the one that we used before. The mass is 3.36 from here. So then we can come here and say 3.36. Then we get the answer, 0.24 moles per cubic decimeter. So if we use if we use this formula, we don't have to do anything else. So this is mole per cubic decimeter. So you can do it the other way, or you can do it this way. The second formula does not have a small letter n, see? So we don't have to find it. We can just go straight to the answer. But then I just wanted to show you an alternative way. So let's go to 6.3. So before 6.3, there's a statement, isn't it? They say 25 cubic centimeter of a potassium hydroxide solution of concentration 0.25 mole per cubic decimeter completely neutralizes a dilute solution of sulfuric acid, H2SO4, in a flask. The incomplete equation below represents the reaction that takes place. Okay. So this is what happens here. This is what they gave us. Okay. And so 6.3.1, they say define the term standard solution. So 6.3.1, they want the definition. Okay. Define the term standard solution. So a standard solution, what is it? It is a solution solution of accurately known concentration. This is the definition for standard solution of accurately known concentration. Okay. 6.3.2. 6.3.2, they're asking us to calculate, yes, calculate the number of moles of potassium hydroxide, KOH. So again, they gave us cubic centimeters, okay? So we should change this into cubic decimeters before we do a calculation. It should be converted. So 25 cubic centimeters is going to be equal to 25. And then when we divide by 1,000, it becomes cubic decimeters. So this is 0.025 cubic decimeters. So if we want the number of moles, what do we have here? We have the volume and we have the concentration. So what we're going to do here is we're going to say C equals to N over V. And then we have to change the formula, the subject of the formula, because we want N. So we're going to multiply the two, C and V. So N will be equal to C multiplied by V, which is going to be, our concentration here is how much? Our concentration here, they gave us 0.25. And our volume is 0.025. So we have 0.25 and then multiplied by 0.025. So again, you use a calculator here. And then gives us 6.25 multiplied by 10. So in scientific notation, mole. This is what I get. Okay, this is the number of moles. What? Of potassium hydroxide. KOH. So this is the number of moles for potassium hydroxide. And then 6.3.2. 6.3.2. Now for 6.3.2, we are asked to calculate the mass of sulfuric acid in the flask. Okay. In order to find the mass, we can't find the mass if we don't have the number of moles, isn't it? Because we should say M over M. Okay. This number here, we can get it from the periodic table, you see? But then we still can't do nothing if we don't have the number of moles, see? So if we can get the two numbers, then we can change the subject in order to find the mass. So the first thing that we gotta do here is that we gotta find the number of moles. For what? For sulfuric acid. The number of moles that we have from the previous question This is the number of moles of potassium hydroxide, isn't it? It's not the number of moles for sulfuric acid. So we have to find this for what? For sulfuric acid, H2SO4 from the formula. So what we do here is that we use the equation here, okay? We use the coefficients. The coefficient here is 1. If there's no number here, that means there is an invisible 1. Then here there is a 2. So, oh no, this is 6.3.3. Okay, my mistake here. This is 6.3.3. So we can see from the equation that when we look at, we have to look at the ratio, isn't it? The ratio of the two things, which is what? Which is 2 is to what? Is to 1. You see? According to the balanced equation, the balanced equation gives us the coefficients. So we take the two coefficients of the numbers, of the, the chemical formula here, okay? So the coefficients for potassium hydroxide and sulfuric acid. So the number of moles for potassium hydroxide, isn't it? We know them. We found it here is what? 6.25. Okay. But then the number of moles this side, we don't know it. So then what do? We use the ratio. Then we're going to say, therefore, X will be equal to, we say this multiply by that, divided by this. See, so it's going to be this multiply by that divided by this. So it's going to be 6.25, then multiply by 1, then divide by 2. So we go like this, and then we go like that. This multiply by this divided by this. And then you use your calculator. So you use your calculator, you get, so it gives me 3.125. 3.125, okay. And then we're going to say multiplied by 10 to the power of -3 moles. Okay, so these are the number of moles for what? For sulfuric acid, H2SO4. Okay, now this is the moles, because it came from here, isn't it? Remember that 6.25 had this, isn't it? So we have to bring it back here. Okay, it wasn't just 6.25. So now that we have the number of moles, okay, because that is what we were missing here, remember, for what? For sulfuric acid. So now then that we have it, then we can use the formula, see? So then we can come here, then we say N equals to M over M. Then we can change the subject. Then we can say, therefore, M, because we're looking for the mass, M will be equal to N multiplied by M. So we do cross multiplication. Okay, this multiply by that. So then the N is that 3.125 multiplied by 10, -3. And then the M, we get it from, we should go to the periodic table. Okay? We have hydrogen, we have sulfur, and we have oxygen. So for sulfur is 32, okay? So it's 32 32 here, and then we have oxygen here. We have oxygen here, which is 16, and then we have hydrogen there, hydrogen, which is 1. So there is 32, 16, and 1. So then we're going to say 1 and then multiply by 2 plus 30, S is 32, and then plus 16, and then it has a 4. So we multiply by 4. Okay. So then it gives us equals to, so we add those numbers there. You use a calculator. You use a calculator there. So it's 10 negative 3 multiplied by 98. And then you use a calculator. You use a calculator here. So it gives me 0.31 grams. You can leave it in 2 decimal places because it's a final answer. Unless you are asked otherwise, you should always leave it in 2 decimal places. Okay? So now this answers the question because that's what they asked us to do here, isn't it? They said calculate the mass of sulfuric acid in the flask. See, so the first thing is that we had to, this ratio 2 and 1, it comes from where? It comes from here, the coefficients, the 2 here and the 1 there. So there's nothing there. I said that if there's no number, you assume that there is an invisible 1. That's what I said. So that's what we get. So it means that potassium hydroxide and sulfuric acid is 2:1. And this, we have it from where? From here. Okay, so we say what? This, multiply by that, divide by that, in order to get an X, because we don't have the number of moles for sulfuric acid. So we do it here, then we get the answer, and then that number of moles is the N. So the N can then be used here. So we change the subject here. Then we can use the N here to find the mass. So this one, we got it from the periodic table. Okay, this is 2. So we multiply 1 by 2. There is nothing here, so it's just 32. O is 16, so it's multiplied by 4 because it has a subscript 4. Okay, so when you add all those numbers, you get 98, and then you multiply by that, you get 0.31. Okay, so yes, so that was it for question 6 here. So I think let's leave it here, okay? Let's leave it here for question 6 and for lesson 2. So yes, guys, keep on engaging in the comment section, okay? Ask your questions and let me know if there is something confusing, okay? Leave your comments in the comment section and feel free, okay? Feel free in the comment section to ask me whatever you find confusing, okay? So let's leave it here for lesson 2. I hope you tune in for lesson 3, okay? We're going to do some more. I'll bring more questions. I'll bring another question and we do some more of this. Stay focused. I'll see you in lesson 3.